Okay, here we are, example 1. I don't know why my pen says shift every time I write with it, but we're going to deal with it. I spent 10 minutes trying to figure it out. So graphically find the solution set to the equation. So notice they've got the equation set up for me already. That's what makes this different from any other problem we've done so far, is that they were always 2 separate equations asking us to find the solutions. Here, because we don't see any y's, they're only looking for the x values. So we are going to use this green blob up here that says to, whenever you're given 2 equations that are set equal, you can separate them into 2 y equals equations. So, oh boy, don't move anything, just separate them into 2 separate equations. Y equals the absolute value of x minus 5, and y equals negative x plus 5. It is telling us to use a graph to do this. They want us to graphically solve here. So we need to use our grid. We can start by graphing the blue line, easy peasy lemon squeezy, because it's a line. I know it has a y-intercept of 2, 3, 4, 5. And negative x means we go down 1 over 1 for a negative slope. Doot, 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 doot. Make sure you're using a ruler to make your line nice and straight. And don't forget to label it as well. Color coding helps too, makes it a lot easier. Okay, so now note on the purple equation. The purple equation has an absolute value. You need to remind yourself that this should look like a V. A lot of you made that mistake in our first couple of lessons when you graphed an absolute value and you ended up with a straight line instead of the V shape. I'm going to use my calculator to get some points to plot to figure out what that looks like. So remember, to find absolute value, I hit the math button, I arrow over to number at the top there. ABS is that first choice. And both the x and the minus 5 are inside of the absolute value bars. It's important to pay attention to that. Okay, so getting a picture of a graph, I can see that it looks like a V. I can see that this point right here, 1, 2, 3, 4, 5 on the x, is where it starts turning around. Yeah. 5 on the x, then it starts going backwards. So 5, 0. 1, 2, 3, 4. Oh, look at that. That happens to be our point of intersection there. That's nice. And then it looks like we're just going 4, 1, 6, 1. So 6, 1, so 4, 1. Doot, 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 doot. Oh. Ooh. Ooh. This is an interesting problem here. Oh boy. And that's y equals the absolute value of x minus 5. And I'm just going to plug this other one into the calculator as well to make sure I'm not missing anything here, because this is a fun problem then. Negative x plus 5. Come on. Oh my goodness. It's like my first time using a computer or something. Holy moly. Oh my goodness. I don't know what's going on right now. Whew, okay. I swear. Technology is going to destroy me. Yeah, so I am right. So that does like overlap with that. Wow, okay. What a quite fun example here. So notice that one side of our absolute value graph is going to literally line up with all of the points on that one side of our line. So both of these lines or both of these graphs, because absolute value is not a line, both of these graphs are going to continue going on in this direction forever, which means that this actually has an infinite number of solutions. But there's solutions that are only less than or equal to 5. So this was an interesting example. You won't see one like this. Your solutions are all x's that are, well, I can just write x is greater than or equal to, nope, less than or equal to 5. Because 5, 4, 3, 2, 1. Whew. All right, that was an interesting problem, to say the least. Yeah, you will not see one like that on your homework or your test. That's a very interesting case.